Okay, YouTubers, welcome to tonight's extra video, which we've been starting to put on midweek, all about different engines and old films. So this week is all about the V12 Jaguar engine and the development of it. Now, I've got a video found on the internet and I've copied it, and I'm going to play it to you next. It's about half an hour long, all about the 5.3 litre, the earlier type V12 engine. This is my personal XJ81, which I do live for the day I can get to it and weld sills on it and put it on the road. I've just fired it up. It's a real piece of kit, this. It's not an XJ40, it's an XJ81. It's a totally different chassis, made wider so that it can accommodate the large V12 engine, which is now stroked to 6 litre when they put it in this, and it had a better fuel injection system, etc. But I've just got some critics here with me. Might want to say if you...
probably the right word.
Bergerac, what is your thoughts on the Jaguar XJ81?
Well, I quite like them as a car. Not this particular one though. It's suffering, should we say?
It is suffering, but it is a survivor, and
it has survived so far.
And there may become a time in my life where I can actually devote the time to sorting it out. Now, the relevance of Nigel being on the video is the reason I bought this car initially was because Nigel's got a V12. What he does, a Daimler, isn't it?
No, XJ12 Sovereign.
Oh, beg your pardon.
X300.
X300. So he's got the later shape, but with the same V12 engine. And he said to me, "Come and have a go in this before you poo-poo it." So I was like, "What's that big old long thing all about?" And I drove it, and it was amazing. Electric. It was fast. I was really impressed.
You got very excited.
I did, and about a month later, I found this on the internet and bought it. I put it back together. It had a few engine problems, and I have, to be honest, I have neglected it. It lives outside. I do keep it clean, and I'm just itching for the day that I can get to it and it needs some sills welded on it. It's just got a little bit squidgy at the front down here. But anyway, we'll have a look at the engine, and I'll stop waffling. And look at that. I mean, they're never going to make anything like this again, are they? Look at that. Absolutely beautiful. It's engine from one end to the other, and you can't really appreciate how smooth it is, but it is super smooth. It's got a lovely dashboard in it as well, and I do believe these cars may go up in value at some point, because what's happened is lots of these cars have been broken for spares because of the low value. You can buy a mint one for 10 grand that's been looked after all its life, you know. Anyway, we'll call it.
They don't all have this special registration plate though that's very apt for you. It says XJ12 tit, is that?
No, it says XJ12 717 Bergerac.
Oh, sorry.
You horrid man.
I think it suits you.
I'm seriously thinking of removing you from Sugar Tube.
Well,
you know, no more fame when you go to the NEC.
Oh, I see.
People pulling you out the crowd.
You just watch the subscribers drop off, though. You know,
Oh.
they're here for me, not for you.
Brilliant. Right, well, we'll knock it on the end of that. Hope you enjoyed the video, and I look forward to seeing you all Sunday night at 7.
A new sound comes to Myra, the research proving ground of Britain's motor industry. For the first time for 20 years, a completely new sound from Jaguar. For the first time ever from the factory that won 5 times at Le Mans, the unmistakable song of 12 cylinders in full cry. Jaguar's engine for a new generation of road cars worthy of the name they bear.
That is, with all the auxiliaries, the air cleaners, the car exhaust system, it develops 272 horsepower. It is substantially an all-aluminium, or should I say aluminum engine. It has 7 main bearings for the crankshaft, and a new feature for us at Jaguars, a single overhead camshaft per bank.
So far so good, but why 12 cylinders?
Well, we wanted to produce an engine which was outstanding. We want to sell quite a lot in America, so therefore we felt it should be something rather better than the run-of-the-mill V8 engines such are in common usage over there. the 12-cylinder was obviously a good choice. It also has the technical excellence of extremely smooth running.
In fact, the V12 solves many of its own smooth-running problems by virtue of its design, doesn't it, Henry?
By virtue of its inherent characteristics.
Yeah.
There are no out-of-balance forces either from a primary or secondary source.
So the choice of 12 cylinders was not just a question of ballyhoo and bigger for its own sake. It was bounded by technical logic.
Oh, yes. Yes, this was thought of a lot, and the 12-cylinder was decided upon as being the best solution.
Okay, so 12 cylinders in a V, but why only one cam per bank?
Well, the design of this engine was aimed at producing an engine which was for a quiet engine, a smooth engine, to have the good pulling power in the lower speed range, a good middle range, a reasonable top horsepower, and our thoughts on this brought us to a single camshaft per bank, very much because of the simplicity of the drive.
But you really can get the performance with only the one cam, can you?
Oh yes, this is related largely, Mr. Baxter, to the cylinder proportions. We'll come to this later, but we can get adequate sized valves in for our breathing, and we've got extremely good low and middle range torque. And there is another advantage of this single overhead camshaft layout, is one of weight. As you know, we did a twin cam and a single cam version in the development of this engine, and with this single cam layout we saved 22 pounds per head assembly, nearly half a hundredweight on the engine.
And overall simplicity as well as weight saving, of course.
Absolutely.
And you decided on a flat cylinder head.
Well, we had done quite a lot of work at Coventry Climax on the flathead. We had found that the flathead was rather better than the wedge head, which in itself was better than the bathtub type of head. And with the cylinder bore, large cylinder bores, with the adequate valve sizes, the flathead gives us very, very excellent results.
There's one other point, Walter, and that is that we did a tremendous amount of single cylinder test work with
Specially built engines.
Specially built engines for with this bore and stroke ratio, and we tried twin cam heads, wedge heads, flat heads, and on these engines we did a lot of our early development form on the development of this shape of combustion chamber in the piston.
So the simple answer to the question why a flat head is because it's best.
It is best for the application in mind.
Right. You've already mentioned that you have a lot of aluminium or aluminum in the engine. This is presumably to save weight.
Largely, yes, but don't let's get the impression this is the first time we've ever used aluminum. It on the XK engine, the cylinder heads, the sump, front covers, bell housing, but the big difference on this one is that we have got an aluminium cylinder block. And we were a little worried in the early days of the development of this engine in case we did have some noise, crankshaft rumble. And in fact, we did build a cast iron version of this engine, or a cast iron version of the cylinder block.
The theory being that the cast iron block would be quieter than the aluminium block.
Yes, that was the idea. Mm-hmm. But in the car it proved not to be so.
And we did have a weight penalty of 122 pounds.
A considerable weight penalty indeed.
Oh, yes.
Did the use of aluminium present any disadvantages, however, in terms of rigidity, for instance?
No, I think that we have designed for this, obviously, and in fact that we know that this engine is capable of absorbing a lot more power than it's developing at the present moment.
And still retain its smooth running characteristics.
Yes.
Right.
You can do this with good design, good ribbing in your crankcase scantlings. This is the important thing. And make them so that they can be cast easily.
Well, let's get back to the vital statistics, 90 by 70. This is a very large bore-stroke ratio, and in fact, the engine is extremely over-square. Why is this?
Well, it suits the design. The larger bore gives us room to get adequate sized valves in side by side under a single camshaft. It gives us a short stroke, which gives us the high speed characteristic of the engine, which gives us higher potential power. It gives us the lower piston speed for the higher crankshaft speed, which gives you better wear factors.
Longer engine life, effectively.
Longer engine life, yes. And the thing also fits in is that we have the bearings determine the length of the engine, and we have most usefully filled the space in the water jackets with large bores.
And still retaining water between each bore.
Exactly.
Which comes in very useful.
Yes.
Presumably those dimensions dictated to some extent the shape of the combustion chamber.
Oh yes, exactly. As Walter just said, we get the inline valves, we can get adequate valve sizes in for this performance.
Can we have a look at your combustion chamber?
Yes,
because
we
it's
can,
pretty.
Yeah, we can turn this round without too much trouble.
That's fine.
Well, here you see the flat head. Fairly simple to machine, you know, two big cuts top and bottom, and it's halfway there. And our combustion chamber is formed in the crown of the piston. And we did an awful lot of development, both single-cylinder wise and also on the full-scale engine subsequently, to develop that shape. And we have found that the shallower we go, the better is the combustion. And compared with other engines, this is quite a unique combustion chamber.
Obviously, and it is so designed to improve the gas flow, basically? Or the smoothness of combustion, or both?
To basically improve the combustion. It's a very lively combustion chamber. And as a matter of fact, we say that we can use a ratio higher. I'll explain this. When this engine started off, we had a 10-to-1 compression ratio, and we could run that comfortably on 100 octane fuel. We dropped it to 9-to-1 because of these exhaust emission regulations, and it will still run on 98 octane fuel. Well, a normal 9-to-1 engine is at 102, 103 octane requirement.
And how does the combustion efficiency meet the emission requirements? Mr. Hassan?
It seems to meet them very well. I wouldn't say it's any better from the hydrocarbon point of view. It does enable us to run possibly a little weaker, which helps the carbon monoxide, and the nitrogen oxides seem vastly better than our old engine, for instance.
Well, we're through till 1974 on nitric oxides without exhaust recirculation, which many people are scratching at now.
So no emission control problem, you would say?
In the future, when they get tougher, we're all going to have problems. Don't let's kid ourselves.
The mixture has quite a long way to travel to get into the inlet port.
Oh, well, there's reasons for this, Mr. Baxter. We don't say we'd have put the carburetors there if we had a free choice, but, you know, Aristotle said that all virtues lie in the mean, and we think we've made a good job of it. But what we have gone for, basically, is this long induction ram, so to fill our low middle range of the torque curve. This is what you use on the road.
And a long pipe is, in fact, an advantage, Mr. Hassan. Because you get a ram effect.
Yes, with this ram thing, if you have a short pipe, you get power at the top end. If you have a long pipe, you get power at the bottom end. If you go in between, you get power in between. It's just as easy as that.
What we have done here is rather interesting. On the first stage of the induction, it's updraft, but in this lower portion here is part of the water takeoff system, the water being extremely hot at something like 100 degrees centigrade, and we sort of cook the mixture in that portion, which vaporizes it, and the mixture goes in a completely vapor form, and gets us away from one of the big problems on exhaust emissions in having neat petrol go in, which raises your hydrocarbon levels. This is the most difficult thing to deal with on the exhaust emission side.
It also increases engine wear, doesn't it? If you get neat fuel.
If you get neat fuel, it's a very bad thing on bore wear, bore scuffing, ring wear.
And cold starting to extreme temperatures?
Yes.
Now, in the ignition system, this is where you really do have something quite new.
Yes, the ignition system is the new transistorized Lucas Opus type of ignition. It is very similar in its theoretically to the system that we used in the race has been used in the racing engines in Formula One for the last 5 or 6 years. The great point about it is that there is no mechanical make and break contact points, and therefore there's no servicing at all, and this gives us a very valuable asset, particularly in the emission field, where the timing remains absolutely consistent throughout the life.
How does the life of the ignition system compare with the total life of the engine?
Well, there's no reason at all why it shouldn't outlive the life of the engine, because it's merely a rotating magnet.
And no moving parts to wear out, effectively.
Purely a rotation.
You're also very proud of your tappet and cam assembly, aren't you?
This arrangement. Now, why not have a look at the pieces here?
Well, let me take the cover off, and there you see it. 3 basically simple castings: the cover, the tappet block, and the head. And here you'll see the camshaft, where we have 7 bearings, like the crankshaft, rigidity again. And this tappet block here is a die casting which gives us good quality of metal. We have a choice in the specification of the metal, and we've chosen one that also gives us good bearing properties so that we can run the tappets and the camshafts direct in the casting. And the cylinder head, again, it gives us a good, clean, simple casting, so we can get rid of all nasty sand pockets, no complicated cores. And it shows you here and here the virtues of not only of this construction, but the flathead again, simple machining, 2 jolly big cuts and you're through.
Well, so much for the camshaft assembly, but I notice you've chosen chains to drive them. I think that'll raise an eyebrow or two, won't it?
Well, we like to draw on our experience. We have had very good experience with chain drives. We have no experience with belt drives. We think that our chain layout, simple chain layout such as it is, gives us a very compact setup. We've done an awful lot of development work on it and devised a simple chain. A single piece chain goes around the crankshaft, the camshaft pulley, the jack shaft pulley, the second camshaft pulley, and back again to the crankshaft.
That's a long way, Mr. Hassan.
Yes, well, interposed are at strategic points damper pads, which have been placed very carefully and moved to give the maximum chain control, plus a very long curved spring damper leaf here, which is made of loaded nylon. It is spring loaded and follows the chain throughout its life with a nice curve.
Walter, there is one other point that Mr. Baxter mentioned on belts, cog belts. With the V layout, having to get to 2 banks, you couldn't use a single stage like we have done on the chain. It would mean a 2-stage. These belts are rather wide, which adds length, crossing each other, and adds length to the engine. And this is one of the most difficult points in engine design today on a sophisticated engine like the Jaguar, is finding the room and getting the drives for all these ancillary units, such as the power steering pump and the air compressor for the air injection.
You've tucked the oil pump away very prettily.
Yes, it's in there. It's what we call the crescent type. It's not unique. It's a standard item on modern automatic transmissions, which have to pump oil at very high pressure. We're not looking for anything like those sort of pressures, but it's got two virtues. It's actually round a crank, takes up very little room, we get a drive for nothing, and what we have found out in its development, we didn't appreciate this when we started, is that it is not sensitive to end clearance. We're running with something like 5 to 8 thousandths part of an inch end clearance. If you step much over 2 on an ordinary gear-type oil pump, you are in trouble.
And this one doesn't mind?
Doesn't mind at all.
And where does the oil cooler go? I can't see it.
You can't see very much. It is part of the sump, and it is actually part of the oil system. We return the surplus oil from the pump, and this goes through a casing with some veins in, and it makes the oil wiggle like this, scrub the surface, and through the center of that is the water return into the pump from the bottom of the radiator. It goes through there, and this has given us a 22 degrees centigrade drop in oil temperature, and has only raised our water temperature by just over 1 degree C.
So it's a very efficient heat exchanger, which works in your favor to counteract climatic experience.
Oh yes, certainly. It takes the heat out when it's hot and puts it in when it's cold.
Perfect. In a single sentence, Mr. Hassan, how would you summarize the engine?
I would say that it is light, it is powerful, we've proven its reliability, and in our opinion it is well engineered.
Mr. Wiley?
I must agree with the well engineered, and moreover we have laid down good facilities for making it so that we maintain a high standard, and I am sure that like the XK engine, which still remains in production, it'll become a world beater.
Okay, YouTubers, thanks for joining me tonight with the extra video. I hope you've enjoyed it. I certainly enjoyed it. It's one of my favourites. I've watched it lots of times. I really enjoy listening to is it Walter Hassan and Harry Mundy, a pair of amazing engineers, and I like where he talks about machining it. He's obviously a production engineer, so he when he's designed it, he's thought about how we can machine it efficiently as well, so it doesn't run into loads of labour time to produce it. So yeah, and the combustion chamber as well, running them compression ratios back in like the 60s or whatever, it's amazing. So yeah, I hope you enjoyed that, and I look forward to seeing you all next Sunday at 7. Bye for now.